My partner's name is Bahram Nurullo, and in this video, I'm going to tell you about our project proposal. So let's take a look at the code. So here we are importing natural libraries. Here we are loading the dataset, which is the audio file, and normalizing the value for the each signal. Here we are. This code means that we are taking the initial 30 seconds of our audio file, and then we save it as loopandcut.wav. Next, let's take a look at this file. So here we are importing necessary libraries, also importing matplotlib pyplot. Here in this code, we are loading and raising the values. Uh, are loading the looping and cut it, which was saved previously, and then normalizing the values for it. Next, in these lines of the code, we are adding noise, generating the random generator. Noise level will be 0.2. So 0.1 is weak noise, and 0.5 is meant to be strong noise. So we decided to take 0.2, which is almost in the center. So next, noise is equals the random variable from 0 to 0.2, random normal variable. And next, we are creating xnoisy, which is x, which is the signal plus the noise. The next visualization here, we are putting the graphs for the signal initial and noise after adding the noise. So as you can see, it became thicker. So next, we are here saving our audio files. So here is clean and here is noisy. So let's take a look our models part. So we are importing necessary models and libraries like NumPy, Ridge, K-neighbor regressor, SVR, random forest regressor, and also you can see here scalar, pipeline, and so on. So here we are loading the data, which is clean and noisy WAVs, audio files, and here also we are normalizing them. Also here, now we are main dataset, taking radius to be 21. Radius is something like we are taking 21 from the right and from the left points to the current point and making our predictions based on them. So split is 80%. Here we are splitting them, making a ranged dataset. N is the length of the X, and N train will be the N times 80%. So here we are declaring X train and Y train to be the first 80% of the data of everything for N train, and the rest is for testing part. So here are the list. Here's the list of the models to use. As you can see here, we are using a Reach. Next, KNN, SVR, random forest, gradient boosting, and why they are in the comments, because our computer power is not enough to evaluate all of them. Because at least after Reach, we took 2 hours for us to evaluate the next model, and we think that it will be a really time consuming and would take at least a night to evaluate all of them. So next, best is the variable for saving our model. So here we are starting to create our table for each model, define the characteristics. So start is equals radius plus ntrain, and is len noisy minus radius. So as you can see, we are taking all the points except for initial radius points and next radius points in order not to go out of the boundaries. So for each of the candidates, we're taking name and model, so training them on these sets, training and testing data, and the noise this equals the reconstruct full, which is the function created by us in the other model, which is visuals.py, as you can see here. So we have pre-written functions which will help us in time efficiency. So here, SNRIN is the matrix in order to evaluate the efficiency of the model, comparing the clean version to the noisy one, and SNR out is clean to the denoised one. So which is our result, our model's result. And mean squared error, we are taking it in order to evaluate our denoised model regarding to the clean one. And so we are breathing these characteristics, and then this condition is used in order to save the best one. So it's something like calculating the maximum value over the array. So we are creating a new variable in order to store indeed in it the best one. And when we find something better, we will update the value of this variable. So here we are saving. So as you can see, here is a clean version of this audio file. It's very clean, 30 seconds. So this is cutted one. So this initial 1 minute. So we cutted it. So this is the noise one. We added noise. Very noisy, yes. So next, this is our best denoising. It's not best denoising, but it's rich one. Slightly better, but I think it could be better if other models. So thank you very much. This is our proposal. Hope you enjoyed the video.